Welcome to this side event from grams to tons. My name is Karin Fant and I work for the Swedish Energy Agency and in a project called ClimateSync. And ClimateSync is a project with financing from the EU Regional Fund, as well as the Swedish Energy Agency and the Swedish Agency for Economic and Regional Growth. So ClimateSync is a Swedish collaboration on energy and climate, which with the aim to create synergies and avoid overlaps between initiatives on energy and climate with financing from the regional fund. And in this side event, we will look into different aspects of resource and energy efficiency, and give an insight into how projects financed by the regional fund can contribute to low carbon technologies and partnerships between industry, small SMEs and the research society. We have two projects presenting on circular innovation in materials, Wargön Innovation and LignoCity, and one project working in the field of energy efficiency in the pulp and paper industry, EcoSys. And after we've listened to these presentations, we will proceed to discuss how to go about scaling up this sort of initiatives so that they can be used in industry everywhere. And maybe some of you listeners have experience in how this can be done, and we would like to hear those from you in the discussion. The transition from innovation projects to economically feasible production is very important so that we can reach our climate goals. But before these presentations on about our projects, we will have a keynote speech by Oliver Johnson. And Oliver will give us an outlook on roadmaps and the leadership group for industry transition and how you work there on the theme building momentum through collaborative action. Welcome, Oliver.
Thank you very much, Karin. It's a pleasure to give a few opening remarks today at this event. My name is Oliver Johnson. I'm the head of the Climate, Energy and Society unit at the Stockholm Environment Institute, eceee, at the headquarters here in Sweden. Just a little bit about eceee. eceee is an international research institute focusing on environment and sustainable development issues, working at local, national, regional, international levels, aiming to bridge science and policy and practice. And we've been around for about 30 years. We're headquartered in Stockholm, but we have offices around the world. So we're working globally in the work we do. And eceee acts as the secretariat to something called the Leadership Group for Industry Transition. So I'd like to just speak briefly about that. So we know that industry accounts for roughly 30% of global CO2 emissions, and industrial actors are going to have to reduce emissions sharply in order for the world to reach the target of the Paris Agreement to limit global warming to well below 2 degrees Celsius. And the Leadership Group for Industry Transition, or LEADIT for short, was launched by the governments of India and Sweden and the World Economic Forum at the UN Secretary General's Climate Action Summit in September 2019. And LEADIT gathers countries and companies that are committed to action in energy-intensive industrial sectors to achieve the Paris Agreement with the further ambition to reach net zero by 2050. And at present, LEADIT has members coming from 13 countries and 15 companies, including a number from Sweden. And we've been working together, those countries and companies, undertake work in three main areas. So this is what we do at LeadIt. We work on partnerships for change, and that's where LeadIt is providing an arena for public-private collaboration and for sectoral and cross-sectoral learning. For example, when it comes to innovation opportunities and new technologies, or policies and financing. And it enables collaboration between political and industry decision makers by convening some high-level dialogues to catalyze leadership. Another area of work is evidence for action, and that's where LeadIt is carrying out analyses to improve collective understanding of the opportunities and challenges in industry transitions. And so it's looking at global examples of industry transitions and at key policy and industry levers to facilitate and manage industry transitions. And then the last sort of area of work is on industry transition roadmaps. And we're very inspired by the work of Fossil Free Sweden, which has been working very hard over the last few years to support development of industry transition, or well, roadmaps broadly within many sectors of the Swedish economy, but within industry as well. And the work they've done supporting roadmaps where they're kind of collaborative processes to build sort of shared visions and key kind of milestones and steps on the road to net zero. And that process itself, not just the output, but the process, brings together different stakeholders to sort of dialogue and discuss some of the challenges they face and the commitments they need on either side. What policy is needed, and what can companies do and commit to? And so LeadIt, we are supporting governments and industries around the world or to co-produce these types of roadmaps and pathways to low carbon industry transformation. So, and we're doing a lot of work right now. We've this year spent just trying to gather all the data on roadmap processes for industry in our member countries to see, well, who is doing roadmaps out there beyond Sweden, where we know that there's lots of work being done? Where else are roadmaps being done, and how are they being done? And how can we look across the different types of roadmaps and see where are they similar? Where do they differ? What kind of technologies are they asking for? What policy levers are they calling for? These types of things. And that's really useful, and we're working on putting that up on our website over the next few months. So there'll be a portal there that you can explore to look at those roadmaps. But always in back of my mind is this question: what do we mean when we talk about industry transition? We kind of throw this term around as if everyone knows what it means. And I think a lot of us kind of intrinsically understand or appreciate what we're talking about, but sometimes it helps to think about it a bit more, because I think it's a bit like an onion where you can peel different layers. And so right at the top, there's a kind of simple answer when we're talking about industry transition, which is it means decarbonizing industrial processes, or simply reducing emissions by some level and hopefully to net zero. But if we dig a bit deeper, we see the answer is a bit more nuanced. Firstly, decarbonization can be achieved through different means by ensuring electricity is used from the electricity that's used in any processes comes from renewable sources, and that any other energy needs, perhaps heat or others, are met with alternatives to fossil fuels. So that might be green hydrogen or renewable biomass. But secondly, energy efficiency solutions can also be put in place to help reduce the energy demand in the first place, making decarbonization efforts a little bit easier to achieve. And then thirdly, material circularity can help reduce the demand for brand new industrial products in the first place, meaning less processes requiring decarbonization efforts. And I'm really excited today because we're going to hear some great examples of efforts to improve energy efficiency and material circularity in bio-based industries. And that speaks exactly to this issue. But there's yet another layer to the question, what is industry transition all about? And I'm sure the presentations will pick up on these. And that's the fact that when we think about how to achieve decarbonization, energy efficiency, or material circularity, we are not just talking about installing new technologies in particular companies. That's part of it. But we're also talking about changing business models and affecting the whole value chain and even the broader ecosystem. So for instance, when you want to put in place hydrogen steel making, you're affecting the energy company that provides you with the typically with the energy that you were using for your previous processes. So it's not just about the industry itself, it's about all these other supporting or industries within the value chain, but also within the broader ecosystem. And we're also talking about disrupting established ways of doing things, changing behaviors within firms, but also within consumers. And there's often significant resistance to such change for various reasons, but not least from those who benefit from the current status quo. So you need a lot of dialogue, you need a lot of work to kind of to move through that and navigate it. And given this complexity, it's no wonder that industry transition is such a challenge. We have to look at how to finance the industry transition, what policies might be put in place to regulate them, and what demand drivers are needed to sort of signal to companies to change supply because they're going to have a demand for the green products of industry transition later down the line. And for all of this, it's clear that collaborative action is key to demonstrate how industry transition will not make your company or economy uncompetitive. Instead, it can make it resilient and competitive in the future. It may lead to some job losses. What are they? Where are they? And how can they be offset by new jobs and just transition policies to compensate those people and regions that are hardest hit? And lastly, it can create momentum and so-called ambition loops as the actions of companies, policymakers, and other stakeholders start to reinforce each other and build momentum and then bring more and more people on board. And then you get to sort of a tipping point where it becomes much more established to transition your industry and have these greener industries. And this brings us back to Lead It, because the Leadership Group for Industry Transition, Lead It, is grounded in the conviction that partnership between the public and private sector is key to achieving industry transition. But such partnership cannot be taken for granted. Effective collaboration takes hard work, and we know the current pandemic is creating even greater uncertainty about how international collaboration efforts might evolve in the future. Within Lead It, we're particularly proud of a joint ministerial statement announced in early July. And this statement, signed by 9 ministers of Lead It, member countries, including India and Sweden, who lead It, which called for continued momentum and ambitious action on policy, technology, and finance to ensure industry transition that tackles the climate crisis, creates decent jobs, and delivers prosperity for all. And in particular, that statement noted that low carbon transitions require rapid scaling up of clean technologies and associated necessary infrastructure within research, innovation, and deployment. And I think that point particularly is relevant to today's discussion on learning from the experiences of the 3 Swedish initiatives presenting today. And indeed, these initiatives and this event, I think, are great examples of the collaborative efforts that we need to build momentum around industry transition. So I'll stop there, and wishing you fruitful discussions, and I'm really excited to see the presentations today. Thank you.
Thank you very much, Oliver. Oliver, you will stay on for the discussion at the end of the side event, will you?
I will, yes.
Yeah, that's great. I just looked at the chat to see if there were any questions and for you, but at the moment I don't see any, but I have one immediately. And I think you were talking about the need for demand, to how and what you think is needed to create the demand for green products. how could that be?
Yeah, thanks very much. I mean, this is a topic that is really rapidly coming up on the agenda, and it's something we're focusing on within Lead It over the next few months. What we're hearing from the kind of industries is that one of the challenges is who's going to buy these green products at potentially higher cost, or with an added premium, whether it's green steel, green cement. Different industries are different as well. We've had a discussion recently about green chemicals, but then maybe in the chemical sector, the products are more diffuse. So it's a bit different. But what is needed is demand signals, because that can help in a number of ways. But one is that, well, that signals to an industry that if you transition and invest, then there will be demand for what you that product, that new greener product. So you can feel comfortable and confident in investing. And if you're looking for financing from some kind of lender, investor, they want to know that they're going to get a return on their investment. So they want to know that there's a kind of, this makes sense as an investment because there's a clear demand signal. Now, how do you achieve that? Well, there are a number of different ways, and this is something we're starting to look at and unpick. And I'm not sure there's really been any deep comparative analysis of the different mechanisms, but we know that green procurement is a very commonly touted way to achieve this. And that's done usually at a municipal or sometimes a country level. Is there any opportunity for green procurement commitments amongst a number of countries? So say you take 5 large economies and they all commit to buying X% green cement by a certain 2030, let's say. What would that signal send to cement producers? And the same might be for, we've got other mechanisms there. There are steel buyers alliances. So that's not necessarily at a country level, that's firms that act as buyers who, but countries could come in there as well, but coming together to sort of more than one company committing to buy green steel, but on multiple companies, then that will send a strong signal. You also have more controversial measures like carbon border adjustment. You've got carbon contracts for difference. There's a range of sort of mechanisms that could be put in place, some that are more politically feasible than others. And so we're starting to look into them more deeply, start to understand what are the pros and cons, where might they work, how do they work? Because you can look at it, how will it work for Sweden? How will it work for Europe? How will it work globally? And at different levels, they're going to have different effects. But I think this is an ongoing discussion, and learning more from both the policymakers and from companies, particularly, which ones do they feel might be more relevant or give them a better signal, and investors, the financiers, what do they need? What types of signals do they need that would make them feel more inclined and more supportive of investment? Yeah.
Thank you very much. And maybe there will be more questions in the chat later on, but we'll continue now in the program. Thank you very much, Oliver, to Maria Ström from Wargön Innovation. And Maria, you will talk about your work at Wargön. Welcome here.
Yes, thank you. Thank you a lot. Yes, my name is Maria Ström. I am innovation leader at Science Park on the Swedish West Coast. And today I will talk about decarbonizing industry by focusing on bio-based materials and textiles. And I will also talk about how we do this in practice. So I'm happy to have this agenda set by Oliver in the first place about how we should procure or how we should work with different actions. But my focus will be on bio-based materials and in this session on textiles. And I hope I can switch the slides here. I don't know, Liz, if you can help me out or.
Maria, I'll control them from here if you just let me know when you're ready to move on to the next one.
Okay, you take the control then, Liz. I can move to the next one, please. So, okay, here I can see these ones maybe. No? Yeah. So was it me or you who changed the slide, Liz? I'll try to cope with this. Okay, so when I start, I wanted to state two facts. That we need to lower the carbon dioxide emissions, and this cannot be done by putting all the efforts into one solution. So I guess we all can agree on that it's really time for a change. And the way we do change in my workplace, it's that we work with entrepreneurs and we work with materials. I will try to move the slides. No, I guess you can have the command list. Thanks a lot. We know also that our choice of raw materials strongly affects global carbon dioxide emissions. And there are, of course, a lot of materials around here, but in Wargön Innovation, we focus on two kinds of materials. Resource-efficient raw materials, such as used textiles, and also bio-based materials, such as forest products. And in this sense, we focus on cellulose. I know that Maria is going to tell us in the next presentation about lignin, but our focus in Wargön is the cellulose. What we do with these raw materials is that we work with entrepreneurs, and they have ideas on how to use these kind of materials into new products. And everything we do at our place is to try to develop materials that will lower the carbon dioxide emissions. So please, the next slide. This is my workplace, and as you can see to the right, we have a symbol that has been with us for many years, and it's fitting well into this seminar, the gram, kilos, and ton scheme. And we know that there are a lot of inventions in grams, and there are also a lot of customers who wants to buy these new materials, but there are missing links in the kilo step. How can we go from the gram to tons? My workplace is part of a big science park, and what you can see in this picture is not the whole science park, it's just the workplace where I work. And also connecting to Oliver's public-private collaboration, this is a publicly funded organization that supports entrepreneurs, and we get funding from the structural funds in EU, also regional funding, and we have also municipality funding in our budgets. As I said, the focus is biomaterials and textiles, and we focus on helping out SMEs. We do that both with the technology development and business development. And we have a large cooperation with a lot of different actors like institutes, universities, businesses, public organizations, and NGOs. We are about 10 people at my workplace, and today I will concentrate to speak about how we work with entrepreneurs and how we develop textiles within that sense. But to get some glimpse of why we're choosing to work with textiles, I would like to guide you through what is the status when it comes to textiles and global emissions. So please, next slide. Here you can see how our consumption of textiles have been increasing since many years. We have about 100 million tons of textile consumed every year today, and just as a comparison, I could say that in the 1960s, we had 15 million tons. So it has been a very large increase within these 50 years. And going further, we see that we will possibly go up to 300 million tons a year in 2050. That is about to triple the amount that we have today. And also these consumption of textiles has a very severe environmental effect. carbon dioxide emissions, absolutely, but another example of how textile consumption is affecting the environment is on the right-hand side. You can see the Aral Sea. In the 70s, it was the 4th biggest sea in the world. And you can see the years there, 1989 and 2014, that due to irrigation on the crops in the area, the Aral Sea has disappeared. And we know that a lot of the crops grown in that area is cotton. So having in mind these 100 million tons of textiles every year that is put on the market, about 25 million tons is cotton. And we have reached peak cotton, so you cannot grow any more cotton because that will severely have effects on climate. So that is a challenge that we have. We want to use more bio-based fibers, but there are a lot of fibers that are fossil-based in the textiles. So please, the next slide. Here you can see on the left side that the fossil-based fibers are about 60–65% of the whole global fiber distribution. And you can see cotton, and there are also a few other fibers that are bio-based, but mostly you can see the fossil-based. And if you recall the 100 million tons that we are using today, and I said that 25 million tons of cotton is top, and you're going up to 300 million tons within 20–30 years, then you will see also that the fossil-based cotton fibers is going to be the one who is increasing. And in oil, if you measure in oil, you know that today it takes about 98 million tons of oil every year to produce both cotton, but of course most of it is to produce the fossil-based textiles. And if we continue in this direction, this will be tripled into 2050. So there is absolutely a need for change in the textile industry. How can we be more sustainable, and how can we lower the carbon emissions from textile industry when we have a situation like this? So next slide, please. So here is one of the things that Oliver spoke about, to have more circular raw materials. And this is a circle that we are speaking a lot about in the textile industry. We see that we need to work on many different ways to reach this. Just to guide you through the circle, in a perfect world, we have a consumption of something, we get rid of it when we're not going to use it anymore for somebody else to use it or redesign it or recycle it to produce more and design and again have a new textile for buying. But the fact is that 80% of all the textiles that we are put on the market, they end up in incineration or landfill today. So there is a really big challenge now that we have 80 million tons of textiles just going to waste when we could actually have a circular system. So this is apparent to me anyways, that to get hold of this, we need to work on so many different parts. And as also Oliver and Karin was into the last question about how can we change this behavior. Green procurement is very good, and also we have to understand, each one of us, that we cannot continue doing business as usual. We have to change the way we consume things. So this circle is the basis for the work we do in Wargön with textiles, and also the basis for how we work with entrepreneurs to find new ways to get this circle work better. So please, next slide. But there is a large challenge also. You have to be both environmental, work for the environment, but you also need to have the economy with you. And the large challenge with the textiles is that a lot of the textiles have a very low value. As you can see to the left, about 50% of the volume for textiles, this is figures from the Nordic parts of Europe, is so-called cream quality or next best quality for use. And this 50% of the volume corresponds to about 97% of the value. So we have a big pile of textiles where the value is about half of the volume, and then you have less value on the other part. And we need to find ways to increase the value and to increase the possibilities for recycling and make that profitable. And we need a lot of actions and ideas and funding to get this happen. And it is kind of complicated. You can see the next slide. This is a slide from the institute in Sweden called RISE, and it shows just how much you have to take into consideration when you're going to be able to work in the circle. You have collected textiles on the left, and you do manual sorting and put back things that you can reuse, but then you have to sort on materials to try to find the way for where is the cotton going to go, where is the polycotton going to go, where is acrylic materials or wool acrylic blends. So you need to know exactly what kind of material you have in these fractions to make it be able to recycle. And I will not go into all these different parts to the right, but you can see that there are many parts and you have to know exactly what kind of material you put in these processes. So there are challenges with this. And the next slide is a picture on how collaboration can help this out. I have put the circle again at the right and the pile of textiles. And one thing I missed to put on this slide is that the thing that is missing is also textile sorting facilities for all these volumes. Only in Europe, we have about 1-2 million tons of textiles that are collected every year. And we have also in Europe a decision on a new waste directive, putting it to from January 1st, 2025, all the different member states in Europe need to collect the textiles separately. And then we will have an increase of about 2 million tons of textiles and more. And we have a capacity to sort of about 500 tons of textiles, or 500,000 tons of textiles. So we have a big lack of capacity for sorting. And we do not have either a material sorting facility. So there will be a big effort to just build up sorting capacities and also to sort on both reuse and to sort on materials to get this happen. So we need really a systemic change. We need many and new innovative ideas how to use this material. And we need more and scale up recycling and redesigning processes. And two other things that are also going to be needed in this is the standardization issue. We need to standardize materials for recycling. And we also need to be better in using digitalization. So this was kind of an odyssey very quickly about the textile industry and the effects on the environment and what you really need to do. And to sum it up, my next slide, I have been writing up how we are working with this at Wargön and how our part comes into this puzzle and how the entrepreneurs come into this puzzle. You see our building again, and you can also see on the right an interior photo of our textile sorting facility. We have a small pilot plant in our facility, managing about 500 to 1,000 tons of textiles every year. So we support entrepreneurs that have ideas on what to do with these textiles, and they can come to us and be in our building and make tests and so forth, and work to see can we do anything from these textiles in the future, new products. You can also see a photo on Tud. It's an entrepreneur that is in our building, and she works with denim materials, and she makes a wood-like Tud, a textile wood material, and she made an electric guitar and a shoe just to show what you can do with this material. And we also have a picture of furniture where we had the students from a university close by who made new furniture from old textiles. So this is some of the examples that we have when we are heading up in the gram, kilo, ton symbol. And I would also like to say what is it we do in Wargön that is helping the entrepreneurs? Well, for the
Maria, 1 minute now.
Oh, perfect. That's perfect. Thanks, Karin. Well, we are a non-profit organization and a neutral partner. That is, our aim is to help the entrepreneurs, and we have no business interest in their businesses. We work with both business and technology, and that is very different. Some entrepreneurs need more business help and some more technology help. We have a physical place to be. You can come to us, you can sit there, you can work, you can explore. We have some technical equipment and you can use these ones, or we can help you to get the right technical equipment. We have a lot of partners to collaborate with, a big network, and we always work in value chains with the entrepreneurs. So to each entrepreneur, we have 5 or 15 different actors depending on how the entrepreneur would like to have it. And we also have skills to write applications, and that is also a thing we need. The final slide I have is that, okay, this is tricky and it's not easy and there are a lot of challenges, but if you never start, you will never get anywhere. So it has to start somewhere. This is also one of our symbols in Wargön. So thanks for listening, and I will also be happy to hear Maria later on discuss about how you can use forests and forest products for new materials. Thanks.
Thank you very much, Maria. There are several questions for you in the chat. I'd like to start by the question, what do you think is the most important support to the entrepreneurs you work with, according to them?
Well, I think that we are not a big organization. It's like feeling at home. And we don't have a business interest in their idea. We want to help them, and we know how to guide them in the innovation system, applications, networking, and so forth. So I think they are seen when they come to us and they get help.
I see. And then there's a question from the chat about the global textile consumption projection you were talking about. Is this assuming that fast fashion in the global north goes on or is even extended, or is it mainly caused by rising development in the global south?
Well, I would say it's a combination, because fast fashion is also taking a lot of precautions to be more circular, and we have new business models evolving all the time also from these companies. But the demographic development is one thing, and also another thing is that thankfully a lot of people get better and better living conditions. So it's a growing population, and it's also a growing middle class who will make the consumption rise.
Mm. And then there's a question about the information that 35% of the textiles produced aren't even sold but incinerated directly. And how can we change that?
That was nothing in my slide, but that is also,
that was another information.
Yeah,
from.
But I don't know about that figure, but it's absolutely so that there is an overproduction of textiles, because today you are producing on an assumption that people will buy certain things. But there, of course, is a lot of overproduction, and this overproduction is sometimes given to charities and sometimes maybe burnt. I don't know about that, but we need to find new business models also for maybe more on-demand productions, and different business models, I think, would solve this better, because nobody would like to have this overproduction. And we know also that the production part in textiles causes about 80% of the carbon dioxide emissions. So if we can use a garment from our wardrobe, or if we buy secondhand, it's always better than to buy a new thing. It's always much better.
And there's a last question. Could you tell us a little bit about the most promising and innovative materials you're dealing with currently?
We have been working a lot also with Renewcell. I don't know if you know about these guys, but our mission is to work with the entrepreneurs when they have ideas and they will want them to fly by themselves. And I would say that Renewcell is one of these flyers that now have a test and demo facility for recycling of cotton of 7,000 tons. So they have their own facility now, their own business, but they started to work with us on the idea. So I think that is a good example on how we work with entrepreneurs, and then they go for themselves and produce and have bigger plans for production.
Thank you, Maria. We have to continue in the program. There's one more question, but we will, and one more for Oliver, but we can get back to those in the discussion part. So I will now hand over to Maria Ölmhult from RISE, who will talk about the project LignoCity. Welcome, Maria.
Thank you, Karin, and thank you for the opportunity to speak today about LignoCity. I work as a project manager at RISE Lignodemo, which is a test bed where we produce lignin out of black liquor. And lignin is the other part of the wood. Cellulose was what Maria spoke about. They use, and we use the lignin. And I'm very glad to be part of these interesting projects such as LignoCity, which leads to a sustainable future and decrease the carbon dioxide footprint with using new technologies. And in my free time, I like to spend it with my family, my horses, and I also do Zumba. If Liz is kind and change to the next slide, please. I will brief you about what RISE is. I will present what our test bed can do and what is lignin. And I want you to know more about the project LignoCity after this presentation. If we take the next slide, Liz. RISE is the Research Institutes of Sweden. It's an international collaboration with industry, academia, and the public sector. We ensure the competitiveness of the business community and contribute to sustainable society. Among us, there are 2,800 employees that support and promote all manner of innovative processes. And RISE is an independent state-owned research institute that offers unique expertise and about 100 test beds and demonstration facilities, instrumental in future-proofing technologies, products, and services. Next slide, please. So within RISE, there are, as we say, among 100 test beds and demonstration facilities. And in a test bed, you can do what you like to test without interrupt your current production for running the tests. You can test and scale up your products and processes of the future under realistic conditions. You can work on direct and confidential assignments or in research and innovation projects together with more actors. You can access a well-developed network of actors and expertise that can contribute to new solutions and business opportunities. It's a reduced risk to use a test bed. It's an effective product, process, or method development. It has lowered cost of development and production, shortened times to introduction on the market, and it decreased the company investments in equipment. If we move to the next, thank you, Liz. This is our test bed, LignoDemo. It's located in Bäckhammar in Sweden, between Stockholm and Oslo, at the north of Lake Vänern. It was established in the year 2004, and LignoDemo is the only plant in the world with flexible production of tailor-made lignin grades in so large amounts that you can scale up into commercial scale. So we can go from gram to ton. And the IP for the LignoBoost process we use, it's owned by Valmet AB. Except for in Bäckhammar, Sweden, there are 2 commercial plants in the world, which is Domtar in the United States and Sunila in Finland, where the same process is used. So here we do separate the lignin from black liquor in a step-by-step process, which is called LignoBoost. And the main customer groups visiting us is from the pulp and paper sector. It's suppliers to lignin separation and refining, companies interested in development of lignin, which is bio-based products. And within LignoCity, the project, our testbed also strive to attract more small companies and innovators. Next slide, please. So what is lignin then? In one sentence, it's the natural glue of wood. It's an environmentally friendly raw material with great opportunities. The wood component lignin is an aromatic compound that exists in all plants, so all vegetation consists lignin. A tree usually consists of about 20 to 30% of lignin, which is the glue that bonds the cellulose and fibers together and contributes to the strength of the tree. At the paper and pulp mills, huge amounts of black liquor are being burnt. It's the rest product of the production that's used to create steam and green energy for the mills. So it does have its purpose. But however, if the lignin is extracted, it's possible to create a higher value. You see that more than half of the black liquor consists of lignin, and the material's potential is great. Lignin has properties that can be used to a wide range of applications. If we check the next slide. So there are examples of development for biofuels, carbon fiber, bioplastic, food flavoring, and construction material. They have come a long way. Few people know about the lignin's possibilities and benefits and how lignin opened doors to more environmentally friendly products. So we need to help and spread the word about lignin's large possibilities. LignoCity is the project where we want to show the possibilities with lignin and our testbed to more actors, especially small and middle-sized companies or innovators with an idea to scale up, just as Maria at Wargön. Next, please. So if you have an idea you want to develop or a product, it's a good idea to turn to LignoCity. With a great network and knowledge, LignoCity can lead you to the right persons and competence. We can open doors to necessary resources such as facilities, workshop, and financing. With lignin, we can create and develop environmentally friendly and bioeconomic solutions. Next slide, please. So LignoCity is a 3-year project. The project members is RISE, the cluster paper province that's in Värmland, the municipality of Kristinehamn, Karlstad University, and also a few companies are partners in the project. And as a company or innovator, you are in good hands if you turn to LignoCity for development with lignin. We have many years of experience from working with and researching the material. And at the test facility in Bäckhammar, we have the resources necessary to practically explore possibilities with lignin linked to new products. Today, the plant is the only one in the world that can produce tailored lignin qualities in enough quantities for scaling up to larger production. Next slide, please. Go is the way to realize your product. Go has been created to speed up the process of going from one idea to a finished product. Because it's often risky, sometimes tricky, and it costs time to come from an innovative thought to a real product. Because of that, it's important to have the competence, skills, and available technical resources. And having this, the way can be shorter, the cost and risk less. And to succeed, we have created Go. Go is about availability of international skills, technical and industry resources to smaller companies and startups or innovator companies. Go is a unique teamwork between industry, academy, the cluster paper province, RISE, and the region Värmland. Supported by Go, we want to increase the amount of commercialized technique in forest bioeconomy and establish the region as a center for companies with the aim to build market using the transformation from fossil to green economy. Next slide, please. So the 3 steps start with number 1, to go aware. That's when we hopefully get to know you and you get awareness and take part in a world-leading knowledge and competence in lignin, external environment monitoring, education, seminars, workshops, conferences, and networking. The activities are intended to provide insight to business opportunities connected to lignin and knowledge needed to move forward with a new product. You get awarded a personal guide, an enabler, who give access to national and international industrial networks and resources. And this person will guide you through the next step. Next slide, please. Step 2 is Go Product, where we've hopefully developed the first product at the lowest cost and risk. With support from technical expertise and industrial resources, previously only available for larger companies. You get access to everything needed to produce a first product, such as instruments and facilities. You get access to large scale of lignin. You get support completely adapted to your needs and made up to speed the development for a minimal cost. And next slide. We take step 3 and go scale. This is when we go from producing just one product to scalable production from gram to ton. Your needs lead the way, and we just make the roads towards the goal straighter, clearer, and smoother. You get support of technical expertise and industrial resources, access to RISE structures for certifications, contact networks for leading R&D departments, and the cluster paper province industry entrance support. And yet we have the raw material lignin for your product. Next slide, please. So here you hopefully see yourself as the company in the middle with your dedicated network enabler helping you out to guide you through the process to bring your product from an idea and to the market in the best way. So after the initial steps, the company is a natural part of the industry with initial contact network and an established relation to the dedicated network enabler, being speaking partner and door opener to the industry, the official room, academy, and the forestry innovation system. Next slide, please. We mentioned partners in the project before, and Rencom is one partner that successfully have developed bioplastic out of lignin. So from lignin produced in our testbed, biogranulates are made. And Rencom combined lignin and biocomponents into a renewable and functional biogranulates called Renol. And this replaces fossil-based plastics as a good example on what lignin can do. Next slide, please. And in the project, we try to attract persons, innovators that want to scale up their idea. And one company that we have connected to is eceee. They are now a company on the way to our region to build their pilot in our facilities. They want to apply one person here on site and build a pilot for their BioFlex process, which is a recyclable ionic liquid that separates the different components of biomass, for instance, the cellulose and lignin, but byproducts such as heavy metals present in waste wood, they can be recovered. And why do they want to set up here is that they have given the support from their area, the facilities we have, and the raw materials and technical skills. So Go has been implemented. And the next slide, please. So now I hope that you know about what RISE is, what our testbed can do with our lignin offer, and that you know briefly what is lignin and more about our project LignoCity. Next slide, please. So thank you so much for listening. And if you want to know more, please be happy to contact myself or my colleague Robert. Thank you.
Thank you, Maria. Very interesting, and especially to hear about the flexible production possibilities that you have in your test bed. Very interesting, and that there are only 3 such places in the world, test beds in US and Finland, I think you mentioned. And I would like to ask you, what would you say is the biggest challenge in your project?
To make innovators aware of that we exist, how we find each other, how they know that we are here and that we want to help them. That is, I would say, one of the biggest challenges, to get to know each other, to find each other.
And how do you go about that?
we use the network that we have, and the ClimateSync is also a way of networking when we meet the project leaders of the projects together, and an event as this is also a way of networking and to spread the word about that we are here in Bäckhammar with LignoCity and the Lignin. That helps, I'm sure.
Yeah, absolutely. There are two questions from the chat for you. First is, how is lignin used today, and why are the uses you presented better?
The only commercial application that you can, so to say, meet in your day-to-day life is in asphalt. So there it is used. And many of the ideas, they are still in small scale, in gram. Plastic is another application that we saw that is coming to the market thanks to Rencom. And then they spin carbon fiber out of lignin, but it's yet in small scale, but it has great potential to grow. But someone needs to take the idea from the lab to the market.
Mm-hmm. Then there's another question here. Can lignin be used to produce plastic shopping bags? Does production of such bioplastic offer lower carbon footprint?
Yeah, in case you use it, yes, it does decrease the carbon footprint. Of course, I'm not sure that it can be used for the thin plastic in the bags yet, because you need to mix it with others.
How much lower would you say it is in carbon footprint compared to conventional plastic bags?
Oh, I don't have the numbers. That one I need to take with me and come back with instead of guessing. I'm sorry.
That's fine. I was thinking on that question of how lignin is used today. Isn't it simply used for energy production?
Also, to create fuel is a lot going on. Yeah.
Yeah. Okay, thank you, Maria. We will just discuss more later. And now I will hand over to Birgitta from EcoSys. And EcoSys is a project also with financing from the regional fund, which develop efficient techniques for mechanical pulp production units. And Birgitta works at the Sweden University. I don't see Birgitta. Are you there?
Yes, I'm here.
Yes, fine. Yeah. Welcome.
Thank you so much, Karin. And there's also the presentation. Yes, I was asked to talk a little bit about a project that we run at Sweden University called EcoSys, and it stands for Eco-Effective Processes and System. And the area of research is within in pulp and paper, and to narrow it down, it's in mechanical pulping. And the main objective of this project is to increase electric energy efficiency in the mechanical pulping process. So, mechanical pulp, what is that? Yeah, as you hear from the name, it's produced mechanically, and it's a high yield pulp. We have now listened to both Marias discussing what we can do from cellulose and from lignin. And in mechanical pulp, we have all this still in the pulp. It's a high raw material yield of almost 97%. So we keep the cellulose and the lignin and all the wood polymers still in the pulp. This makes it a resource efficient process. And if we have 1 ton of wood, we get almost 1 ton of fiber-based product out of it. So the products that can be made from mechanical pulp are reusable and recyclable, as most pulp and paper products are. However, there's one challenge, and that's quite big. It's a high use of electric energy in the refining process. And And here is a short description of the refining process. When you make mechanical pulp, you feed a huge machine called a refiner with chips. And the chips are ground in this refiner to liberate the fibers from the wood matrix. So there are large discs with a diameter of up to 1.5 meters that rotates. One can rotate or both can rotate. And out of this process comes the pulp. So you feed wood and you feed water and you use electricity and you get the raw material that you can process further into a paper or fiber product. But you can use only water to do that also, and some energy. So when you talk about mechanical pulp in general, people say that, well, mechanical pulp is used for newsprint, paper, magazine paper, and that's a market that's going down. Unfortunately, people are getting digitalized and use computers instead of paper. So why do you work with mechanical pulp? Well, as we've heard earlier from the speakers before me, there's a need for new and improved fiber-based materials for all sorts of things, but also to replace plastics, because we want to get rid of a lot of plastics. And I believe, and we believe, that mechanical pulp has a somewhat neglected potential for doing this, for replacing some of the plastic products, for packaging, for instance. And why do we believe that? Well, as we heard from Maria before me, lignin can be used to produce a lot of exciting products when it's resolved from the wood in the chemical pulping process, which is another pulping process where the lignin is sort of a byproduct. But here we have still the lignin in the raw material, and that can be modified within the product to create a new functionality. So we've discovered that we can use the lignin in the pulp to create high wet strength in products. And so we have a parallel product to EcoSys called EcoMat, which focuses on this, to use lignin and to use the whole pulp to produce really sustainable products. For instance, to replace this grocery bag. You know, the grocery bag, the paper grocery bag, if you put it down beside the car after it has been raining, when you lift it up, the groceries are all over the ground because, well, the paper bag does not really handle the wet, the water. It turns weak and breaks. So that is something we could do something about. Well, to produce new sustainable products, we also need to have sustainable production processes. And we believe that those are equally important. So back to EcoSys. In Sweden University, we focus, one focus area of our process research is to study fiber interactions in processes. And that is not something that can be easily done, since fibers are really, really small, and the processes in our mills is extremely inaccessible. So we need to do something else. There could be some measurements or something, but it's difficult and tricky. So we use in EcoSys models and simulation tools to be able to study or visualize how chips, steam, and water flow through the refiner, and more to pinpoint the refiner inlet. We know from earlier research within mechanical pulping that if we increase the throughput of such big machine, a refiner, we can really make the process more energy efficient. But that is a sort of a bottleneck of the machines. And why is that? So by using modeling, we have developed a little bit better understanding of the process phenomena. We believe that at least. And we have, together with a partner company, a supplier company, developed ideas how to improve process efficiency. For example, one thing we've noticed is that the steam produced in the middle of the refining gap between those rotating plates, and that steam goes both forward in the process but also backwards, and that back flowing steam is really disturbing the feeding of material through the process. Our supplier company partner has developed a new center plate design to prevent steam from flowing backwards and to push chips forward in the process. And here's that center plate. It's shaped like a star. And what we've done within EcoSys is to evaluate the effect of this, if it sort of shows potential as in the models and the simulations. So we've been evaluating this in 2 mills within 2 different companies. And what you can see in this graph is that when you increase production, like this, the blue curve, the power variations really goes down. And that is something that is important because the limitation of increasing production earlier on was that when you increased the production, the power variations really escalated. And you had a lot of power variations, which meant that you could not simply run the refiner with high production. So you had a lower limit. Okay, to summarize the results from these 2 mill evaluations, we see that it's not possible to increase production from 12 up to 20 tons per day through a refiner. And the increased process stability that we saw meant that we had approximately half the power variations that we had originally. And last but not least, we saw that we improved the process efficiency by approximately 30% or 400 kilowatt hours per ton of produced pulp. And in one of the mills, in Mill A, we call it here, we have even more potential because this takes something else with it. If you can increase the production this much through a refiner, the mill can use only the new and more modern refiners in the mill to produce all their pulp. That means it could shut down old machines that are not as energy efficient as the new ones. So this has not been done yet, but that's an additional potential that comes out of this. Another area that we work with within our process research at Sweden University is what we call wood and fiber rheology. Here we do measurements in lab to provide relevant material data to our models. And we do it by testing wood and fiber material under relevant process conditions. Because in tables, we have standard values for material parameters, but that's mostly done in room temperature and low humidity. But in our processes, we have high temperature, steam, pressurized environment. So wood material is also a polymer, as you heard, a very complex polymer, which means that the wood material changes its properties a lot if you change moisture, temperature, and so on. So we need to really be able to predict this. So we've studied, for instance, energy losses in wood, frictional losses in wood-steel contacts, and so on. And also from this part, we want to generate ideas how to improve process efficiency in reality in a mill. So one example also based on these experimental studies is that we've, together with the supplier company, developed a segment surface, a new segment surface out of high friction material. And why have we done that? Well, it's also known from earlier, from researchers from our studies and other researchers' studies, that if you can refine mechanical pulp by using a really small plate gap between these rotating discs, the process will be energy efficient. We've seen that, but we can only run it for short periods of times because it's unstable and very complicated to run. So it's not possible in everyday operation. So this is what we aimed for, to be able to run a small gap for everyday operation, a stable process. So we had abrasive segment material and we've run several mill trials in a different mill, the mill C. And from these trials, we can see that we have potential of reducing the energy consumption or improve refining efficiency by approximately 30% if we compare at a similar strength of the pulp or the paper produced from the pulp. And that's approximately 300 kilowatt hours per air dry ton produced material. So that's also a lot. Now I've presented two different applications that comes out of our cooperation with companies and our research studies. However, we don't know if we can combine this, these results together, if we use the center plate and this new abrasive material, but that would be interesting to study. It's not impossible. And last but not least, I would like to mention a little bit about our Academy Industry co-production. As you might have thought about during my presentation, this is not really a traditional research project within a university. It's a bit different. The main objective is to really reduce energy consumption in the mills. We work in full scale. So we've chosen to have all mill scale activities managed by a partner company colleague or a university company colleague. So we have some foundation within the companies. And why? Well, it makes communication easier, and communication is extremely important to make this work. And also it promotes engagement within the companies. And you easily get more people involved if you have someone in the company who's running it. It's also important for acceptance within the company. So the project gets higher priority within the companies, that we can have seen also. And last but not least, it's important for implementation and continuation after the project ends, because then the company and the mill feel like this is our project, we have run it, we trust the result, we want to continue to develop this. So this is Christer, who is working in Holmen and also part-time at Mid Sweden University. He's one of these key persons to be able to run this kind of project. I had one more slide. Thank you for listening, and thanks to the partner companies of EcoSys, that's eceee, Stora Enso, Holmen, and EMT Materialteknik and Valmet. Thank you.
Thank you very much, Birgitta. It was very interesting to listen to this, and for that you helped us to understand better the process of improving the efficiency. And as you mentioned how you improve the communication with the companies that you collaborate with, I would like to ask you what you think their main driver is to actually work with the university to develop these processes.
Yes, I've been thinking about that also, and I think that two main reasons. One is the long-term perspective that we can have on this type of development or research questions. We can continue for years, while they have projects that run for a maximum of 1 year, and they are so occupied with daily production. And so the second reason, I think, is that we come and we have ideas and we lift and pinpoint important topics such as energy efficiency, and then they, yeah, of course we want to do something on this, and yeah. it's easily forgotten in everyday operation in the mills.
It must still take quite some courage to start these trials.
Yes, and that's why it's so important with communication, because I mean, we run the trials, we could cause a stop in production of a day or so, and that's really expensive for the company.
Oh yes, yeah. There's also 2 questions from the chat, and one question is on the energy intensiveness of mechanical pulp. Is 8 gigajoules per ton or 2,200 kilowatt hours per ton a good estimate for the electricity demand? What do you know? And could you say?
Sorry, I didn't hear the numbers really.
Is 8 gigajoules per ton or equals 2,200 kilowatt hours per ton a good estimate for the electricity demand?
Okay. You say that when you produce a newsprint, it's around 2,000 kilowatt hours per ton if you have a standard production line. Normally, the mills have now reduced it a little bit, and it can be reduced quite a lot. And of course, it depends on what kind of product you produce. That's also something that's good with aiming for this replacement material for plastic. I don't think it's necessary to use this large or high amount of electric energy. You can defibrate the fibers at higher temperature to reduce the energy consumption, and you can still use it in this type of material. It's the newsprint and the printing paper that needs a lot of energy.
And then there's a question to all speakers, so I will start by putting it to you. Would you have any innovative product in your field in mind that you've seen entering the market that you could tell us about?
Not really that's out there in the market, but the closest you can say is that the trays that you have for vegetables or in the shops, you pack food in trays. That's very close to mechanical pulping, and that is developed also now, producing it under different process conditions will make the properties of the trays better. Yeah, but not so many products yet, and we need that.
Maybe I should put that we will continue to the discussion and wrapping up this side event. Thank you very much for your excellent presentation, Birgitta. You will stay on for the discussion now, I hope.
Yes.
And I will take the opportunity to ask Maria Ström if the same question about if you've seen any innovative product that you saw entering the market recently.
Yes, I also saw the question in the chat, and there was another question. What were the key success factors? And I choose to start to address that question. Very easy. Customers.
Yeah, that's good.
And that's not so easy. And you have to have customers, and you have to have a very ambitious and hardworking entrepreneur that is prepared to do the job. That is 2 things that is important. And the things we've seen entering the market, well, Renewcell I mentioned, they have their fibers in new H&M dresses. And also another smaller product that we were working with was a small bio-based, that kind of thing for a syringe in the healthcare sector. So instead of using fossil-based plastic, they used bio-based composites to make something for the healthcare sector. I don't know the name of that, but there is 2 things that have entered in the market.
Interesting. And I think if we take that question to Maria Ölmhult, you already mentioned that lignin is used in asphalt. But that has been in use for a longer period, is that right?
Yeah, for a while, but I also, as Maria read the question in the chat already, and I wrote about the same as Maria said. that you need to really believe in the product and see the possibilities. And here is not the pull system, it's a push system. We must create the market and explain to the future customers that this is the future, because they don't know yet the possibilities. And that's applicable on all the applications that we show about lignin, what it can do. And we really do the journey from gram to ton here. We start in the lab and want to come to the market, and some ideas has reached further. But it's the same, a strong belief in the product and what they can do. I think
yes. Would you like to add something to that, Oliver? Have you seen some interesting new innovative products? I know you're not in a narrow field, but all over, maybe, if there's something you would like to.
Yeah, well, it's interesting, the idea that things have entered the market. I think there's a lot of things on the horizon. There's a lot out there already, but they're maybe not seen as new and innovative now because they're on the market. I think, you know, so there's a lot of decarbonization technologies that exist out there. The one that comes to mind right now is hydrogen, and that's really being tested now in the large scale pilot for hybrid, for hydrogen steel making. And that, I understand, Germany, ThyssenKrupp are looking to do a similar pilot. These are going to be, this is the pilot stage, not at the market, but large pilots. And this is going to be really key to sort of demonstrating at scale that these technologies and hydrogen can really be used. And because I think there's a lot of sort of innovation around it. It's not just one innovation, there's multiple innovations. And I think if you look across industries, you see demand for hydrogen is just huge. And so actually demonstrating this at scale is going to be critical to sort of show that it can actually get to market. So we're not quite there with that yet.
While I have you there, there was one question. Yep. There was another question to start with. Can we see? Yep. Let me see what it was.
I can see it here. It's
great. Incumbent energy players, should they be recognized as legitimate interest or as opponents?
Yeah. This is a fantastic question, and it really, I think we think about this quite often. So let's take LeadIt. LeadIt's working and has within its members existing energy industries or carbon intensive industries. And it always begs the question of, well, should some of these be replaced by new entrants? I think within LeadIt, actually changing the steel industry, changing a lot of these, the bio-based industries or cement industries, is not necessarily the problem. If you can decarbonize them, then the industries themselves or the companies could stay the same. When it comes to things like coal companies or fossil fuel companies, then sometimes it's a question of, do we want to phase them out and bring in new companies? I think the huge influence that these large companies, and actually the energy industries, have a lot more influence than industry, the heavy industry companies, because energy industry is kind of permeates the whole economy, transport, all sorts of consumption industry, household, you know. I think it's hard to kind of not include them in the discussion, or the barriers will just be too high. So you have to consider them as legitimate interests that need to be dealt with. Not if it's too confrontational. I think that's often been the case, and there's a place for that confrontation, and advocacy groups often take that. But I think you have to have that on one side as a lot of pressure coming from that, but you also have to navigate the politics of it and include them and sort of think about, well, if you are going to phase out, how do you work together to do that? I mean, and So I think you have to, in some ways, be pragmatic and take these interests as legitimate, because they've started to become so entwined with the economy. Not least, pension funds of millions of people are invested in oil and gas companies and so on and so forth. So it becomes a real complex web. So you have to start to look at how do we maybe phase out some of these industries, and how do we do it in a way that is kind of in some way managed and facilitated, and the aspects of just transition are considered within there. And to be honest, a lot of those companies are already, you know, they see the future. They've got one hand into renewables. They might be thinking about how can they provide decarbonized energy supply of the future. But you also don't want to forget the new incumbents, the kind of battery manufacturers and others who are really disrupting, and support them. So I think it's not about picking winners, but it's about kind of navigating a very complex political economy.
Thank you. I'll just try to see if there are any questions in the chat that we have not answered. And I see one for Birgitta about the figures you presented, if they are for the best available technology or new installations or representative for the existing technology stock.
Yes, I saw that question, and that's a good question. I did not go into details around this, and the figures I presented with a center plate evaluation, that's basically a representative result for existing technology. However, we almost always compare with best available technologies, because in all these mills that we work, we have new installations and really new technology. So it's still a lot better than the new technology also, but perhaps not 30%, maybe something like 15. But with the new segment material, that's valid for any installation, as we've seen so far.
Liz, could you show the last slide on wrap up about the questions we wanted to discuss on when we've heard about these initiatives, and we've heard Oliver telling us a little bit about what goes on internationally, and what we discussed planning this side event is how do we scale up these initiatives? How do we really get this working? Would any of you want to start discussing that? Maybe Maria Ström?
Yes, and before I do that, I have some questions still in the chat box, but I can also leave my mail address, and then I can answer questions afterwards, so that everybody feel that they have their questions answered. But to these wrap-up questions, well, how we work is that we think that there will be a need of public support in some way. We are publicly funded partly, and we see that to support these small and medium-sized enterprises, they don't have the R&D facilities, or they have ideas, but they don't have R&D facilities. So I think there will be a need for test and demonstration environments that small and medium-sized enterprises can enter. And in these test beds that I represent, we can help them to create the value chains, because we have networks. So I would say that having both regional and local test beds out there in all the countries is needed for getting the innovations started in the gram kilo scale symbol.
And what support, would anyone like to say something about the support needed? I mean, when we look at these initiatives paid for by the regional fund, they are fairly small initiatives, and there's at least 10 times as much needed to scale up, to be fast about the scaling up, as Oliver mentioned, that now we really need to do this quickly. Birgitta, what do you think?
Well, in mechanical pulping, we work with mills, and it's a large scale. But when I told you about these initiatives of using the material for new products, that needs support, because it's really big investments, and it's so risky that the companies do not really dare to do it. So it's also from laboratory to be able to run it in a large scale. It's a huge gap there, and how to go about it and who should drive this initiative. The companies are hesitant.
Yeah, as Maria Ölmhult, you told us that you do this you are already flexible and have the possibility to have large scale production. But still there's so much more needed, and unfortunately we're running out of time. It's already 11 o'clock. Would you like to say just last sentence about this, Maria Ölmhult?
About the support, I would just say very, very quick that funding is a key. I mean, we need investors to find those ideas and be as interested as they need to give fundings to the small companies with the good ideas, and to find a way to do that in a good manner is a key, I think.
Yeah. Oh, thank you very much. It was so exciting to be able to do this side event via Zoom and WOA, and I'm really happy about how it all worked out. Thank you very much. Bye.
Thank
Thank
you.
you, Karin.
Bye.
Thank you.
Bye.
Bye.
Bye.